Okay, we're looking at really 24-1, but it doesn't have much in it, and then 24-2. All right, so the main things we're looking at is I can estimate the solution to an exponential function. Obviously, we don't need a calculator just to estimate. I can solve exponential equations by taking the log of both sides, and that's going to be the big chunk of what we're looking at. All right, but just to kind of hit the few things that are in 24-1 here, if we're given 6 times 4 to the power of x is equal to 96, we just want to solve this for x. All right, and so we're thinking, just like any kind of Algebra 1 solving, we want to get the unknown by itself. So the first thing we're going to do here is go through and divide by 6. All right, and so we're going to get 4 to the x is equal to 96 divided by 6, which turns out to be 16. Okay, and then we're looking, okay, 4 to what power is equal to 16? And we can probably all figure that out, it's 4 squared. But what we want to look at here is, for a more complicated version, if we can take, like say we didn't know, I would say, okay, is this thing, can this be written as a base 4 to some power? All right, this could be written as, so 4 to the x still, and then the right hand side, that could be written as 4 squared. All right, so we've written them both with a base of 4. All right, and so if 4 to some power is equal to 4 to the second power, then we're just taking these exponents and we're saying x is equal to 2. Right? That one was pretty easy because we all knew that 4 squared is 16. But the idea here is you're writing it with the same base. If you're going to get both sides having the same base, then their exponents can just be put equal to each other. All right, so if we look at this one, 5 and 125, we want to get them so their bases are the same. This one, the base is 5. We say, okay, can we make 125 have a base of 5? So 5 to the power of 4x is equal to 5 to the power of 3, right? Because 5 times 5 is 25, and 25 times another 5 is 125, right? X minus 1. Okay. And so now what we're actually going to end up doing is taking this 3 and multiplying it here, and so 3 times x minus 1 just becomes 3x minus 3. And so we have them with the same base equal to each other. Okay? Well, 5 to this power is equal to 5 to that power, so this power is, or this is equal to that. So 4x is equal to 3x minus 3. And then we just minus 3x minus 3x. X is equal to negative 3. Right? And so that's one way to go about solving. It's just taking whatever the number is and saying, okay, can that be broken down into the base of something else? Okay. There are some example practice problems for those on page 372. All right, there's the try these A through D. All right, I'm not going to give you time to work on it right now, but if you want to go back and look at those on page 372, the try these A through D. A, the answer is 4. B, the answer is negative 5. C, the answer is 6. And D, the answer is 2. So if you want to go try them and then see if you get those answers, that'd be good. All right. Kind of moving forward now to really 24-2. We're looking at 3 to the x is equal to 32. I want to know, can I estimate the solution? So what we're going to end up doing is using the idea of the inverse property of logs, which the inverse property of logs, just a reminder, is log base b of b to the x is equal to x, and b to the log base b of x equal to x. So if we want to get rid of a log, or if we want to get rid of an exponent, what we need to do is take the inverse. So if we've got an exponent, we want to take the log. If we've got a log, we want to do the exponent, so that way it kind of cancels out and we're just left over with the x. So here we've got an exponent, and so what we want to do is we want to take the log of that. So we're going to say log base 3 of 3 to the x is equal to, and if we do it to the left hand side, this is, just think back to algebra 1, whatever you do to the one side you got to do the other so it stays balanced. We got to do the log base 3 of 32. Alright, well this side, log base 3 of 3 to the x, that cancels out and just gives us x. Just looking straight here. Alright, that equals, and now really it equals log base 3 of 32. Alright, and so we've solved for x, but that doesn't really mean anything to us. What we want to do next is the change of base formula. So inverse property was here. We're going to do the change of base formula here. Alright, so the change of base formula, log base b of x is equal to log of x divided by log of b. And so it goes from some random base to base 10. Alright, so here we've got base 3, so that would be log of 32 divided by log of 3. Alright, so we just took this right hand side and changed it. These two things are equivalent, so this and that are equivalent, which means it's still equal to x. And then if we go through and do log of 32 divided by log of 3, we get x. We're going to switch to the approximately symbol, 3.155. If you have a calculator, you want to go ahead and end up there. If you don't have a calculator, you want to end up there. Alright, so log base 10. Alright, so if we're doing this like on our test and it's a section we don't have our calculator, this is where I'd want us to stop. Alright, where it's in base 10. Alright, if we've got the calculator, you want to go ahead and do that division and end up here. Alright, we started off with our inverse property, alright, which got the x out of the exponent. So got it just to be a plain x instead of 3 to the power of x, which is a big step. Alright, and then we simplified that log and took it from base 3 to base 10, and then if you've got a calculator, you go ahead and divide it and get approximately the answer. Alright, and so that's estimating our solution, really, is what we're going to call that. And that makes sense when you think of it like 3 to the third is equal to 27. 3 to the fourth is equal to 81. Alright, and we're thinking, okay, well, we are looking for 32. Alright, so it's something just past 27. So I would estimate that it's going to be something of decimal just a little bit past 3, which is what we end up having. Alright, and then we confirm that. Sorry, I didn't do the estimate part at the beginning. Alright, let's look at a one that's a little more complicated than that one. Four to the power of x minus 2 is equal to 35.6. Alright, so So we've got an exponent, so we're going to do the inverse property of logs. So log base 4 of 4 to the x minus 2 is equal to log base 4 of 35.6. All right, that cancels out, and on this previous one, it was just 4 to the x, or whatever to the x. Well, here it's to the x minus 2, so we're left with x minus 2 is equal to log base 4 of 35.6. Okay, so we want to solve for x, so we're going to move, plus 2, and then change this base. So we're going to get x is equal to log of 35.6 divided by log of 4 plus 2. All right, and if we're doing this without a calculator, that's where we stop. If we're doing it with the calculator, we can go that next step and say, okay, x is approximately 4.577. All right, let's try the next one. 12 to the power of x plus 3 is equal to 240. All right, we want to go through and take the log. So log base 12 of 12 to the x plus 3 equals log base 12 of 240. And then log base 12 of 12 cancels, and we're left with x plus 3 is equal to, and then this, if you want to go ahead and get a jump start on the change of base, we could go ahead and say the log of 240 divided by the log of 12, and then to get x by itself, we'll just minus 3. X is equal to log of 240 divided by log of 12 minus 3. Alright, so x should approximately be negative 0.794, because we're going to get something and then we're going to subtract 3, and it's going to end up being a negative. At the beginning, we could have them a little bit weirder here. X plus 4 plus 0.8 equals 5.7. So on one hand, this just got more complicated because they just, instead of it being whole numbers, made them decimals. That's not a big step more complicated. But then in the next step it got more complicated, is instead of it being the exponent by itself, they've added something else. And this is just like solving in Algebra 1, that before you can mess with this, you have to get everything else to the other side. So our first step has to be minus 0.8. So we get 4.2 to the power of x plus 4 is equal to 4.9. All right, once we've done that, we can get rid of this exponent by log base 4.2 of 4.2 to the power of x plus 4 equals log of base 4.2 of 4.9. Right, we did the log of base 4.2 to both sides. It cancels out here, so x plus 4 is equal to that. And if we want to go ahead and write that in change of base, log of 4.9 divided by log of 4.2, and now we're going to subtract 4, x is equal to log of 4.9 divided by log of 4.2 minus 4. All right, there's our final statement. And then if we take it and plug it in the calculator, we get x is approximately negative 2.893. Okay. Try one that involves natural log. They're not more complicated. They just look a little bit different. E to the 2x minus 4 is equal to 148. All right, well, we want to do the inverse of E, which is the natural log of E to the 2x minus 4 is equal to the natural log of 148. Those cancel. 2x minus 4 is equal to the natural log of 148. Go ahead and add 4 plus 4 plus 4. So 2x is equal to the natural log of 148. Sorry, I got dyslexic there for a second. Plus 4, and then divide by 2. Divide by 2. X is equal to the natural log of 148 plus 4 divided by 2. So that would be our final. If you want to go ahead and take 4 divided by 2, we could, do natural log of 148 divided by 2 plus 2. That'd be fine as well. I think it's a little simpler to see. And then x is approximately 4.499. Alright, so if we walk back through what we talked about, alright, just the estimating, I can estimate the solution to an exponential function, really is just taking here and saying, alright, I know that 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81, so 23 to the third, 27 is really close to what I'm looking for. So my answer is going to be 3.1, 3.2, something really close to 3, just a little bit over 3. All right. There will be a section on our test where we don't have a calculator and we are asked to estimate. All right. And then second piece, I can solve exponential equations by taking the log of both sides. So that's where we're given an exponential and we're taking the log of whatever the base is there. And so that cancels out inverse property of logs to give us x. All right, and then we're going to write our final answer if we don't have a calculator in terms of base 10. So we're going to take this here and we're going to do the change of base formula to make it x equals stuff out of base 10. And if we were doing this on a calculator section, we take it one step further and go ahead and do that division and get approximately what is the answer. And that was it from the very first problem. We just kept, making it a little bit harder. Originally had an x minus 2, all right, 2x minus 4. So what was in there got a little bit more complicated, but in essence, it's inverse property of logs, then change of base. All right, so for our assignment, we want to be on page 375. We're going to do 5 through 10. All right, and if you haven't gone back and looked at that website I sent a couple days ago, today I sent SK's website out. She has a couple videos up, but previous to that I sent just a practice website just to kind of gauge our understanding of log and exponential functions. That's a good tool. Go back and check that out. This shouldn't take us that long. If we finish that, go back on the Google website and Google Classroom and check out that I forget whatever the website is, but it's one of the only links I've sent out. It's just a couple practice problems that you click it, it'll give you the answer, it'll let you know if you got it right or wrong.